Okay, everybody should have a sheet. You got these sheets. These sheets are for you to take home. We'll also post these on the website. Friends, or if you're assisting somebody and they want a copy or whatever the case may be, you can kind of print them out. I'm leery to do that because I only have a certain number of questions I can ask, and I'm giving you a whole bunch of answers, and some of these are questions right off the district or the county test, so it gives you a little bit of a head start. But it also gives you a realistic feel for the type of questions that I ask. So, to get things going here quickly, what I'm going to do is, normally this is set up in a station format, and the kids have usually anywhere from 2 to 3 minutes, usually right around 2 minutes, 30 seconds, 2 minutes, 40 seconds, depending on how difficult the test is and how many stations I have, and whether it's district or county or whatever the case may be. And we rotate. This many people, it would be impossible to do that. So I'm going to have you guys work on a section for a period of time. Then I'll give you the answers and we'll work on another section. If you guys, any questions you have along the way, just like during the exam, I want to see the hands up, because it's not going to only benefit you, it's probably going to benefit 24 other people that have the same question but didn't want to ask it or wanted to ask it online. So we can answer it now. I can give you some examples of some things and so forth if you need to have that. So we'll get started. If you guys can all work on the first 8 questions here, and basically these are going to be true false. So you just tell me true, will all the lights light? Not just 1 or 2, if there's 3 lights, but will all the lights light? Or will not all the lights light? Will be false, would that. So just spend a couple minutes, do that. When you get done, so I don't have you bored here, raise your hand so I know how you guys are doing, and then we'll move along to the next section. Yes. And the question, we had a good question here from one of the participants out here, is it's as drawn. So it's not if the switch closes will it light, it's as it's drawn. So if the switch is open in the drawing, it probably won't light. If the switch is closed, then it probably will light. So that's a good point that I didn't bring up, but that's something that could be very confusing. Yes, sir. Along. So for question number 1, up here, will that light or will that not light? Anybody?
It will light.
Yes.
It will light.
It will light. Everybody agree? Anybody disagree? Anybody think it won't light? Do you think it won't light?
Yes,
it will light?
I don't think it
Oh, you don't think it will light. Good question. You don't think it will light? Okay, so let's find out. And the way I like to find out is I like to trace the circuit. So I have my battery source here.
Wait. Go.
Okay, I have my battery source here. Electricity is going to travel, depending on who you talk to, either this way or this way, but I don't really care which way it is. I just want to make sure it makes a complete circuit. Anybody know what kind of switch this is right here? Can anybody tell me? Yes.
Single pole double throw.
Single pole double throw. It's a little tricky, okay? This is a little trickier, but I threw that in so that I wanted to make sure that you guys understand the difference between a single pole single throw and a single pole double throw. Single pole single throw, single pole double throw. And double throw means it can conduct electricity in either one of these 2 positions if you put a complete circuit on it, okay? So I go through here, currently it's touching this contact, I can go around, I can go through here, and I can go through the light bulb and make a circuit. So the correct answer is yes, it will conduct electricity. Even though there's an opening up at the top, I have a route where it can go through the bottom and can conduct electricity. So that's going to be true, it will light.
Can I ask a question?
Yes.
Would it have lit also if it was touching the top? Because it would
If it was touching the top, it would also conduct electricity in this case. But there could be instances where one it's going to conduct electricity and one it's not. One could go to a short circuit, one could go to, you could have a switch turn several different things on. have a motor go this way, have a fan blow this way, similar to what you have in a ceiling fan. Sometimes you want to reverse things. This is the type of thing that you would see for that type of action. For number 2, will that light or not light? It will light.
It will light.
It will light. It will light. Does anybody think it won't light? You think it won't light? You think it won't light? You won't think it won't light? Okay, so let's figure out what it is. Okay? We have the batteries here. One of the first things I look at when I have 2 batteries is I want to make sure they're facing the same direction. So that means the positive comes close to the negative and the positive comes close to the negative. On the diode, the positive side is with the positive side of the battery, so it should light. Okay? Diodes, it's very important when I ask you to draw circuits. This is why I want you to have the plus or minuses on the battery, and this is why I want you to have the plus and minuses on the diode so that I know that they're hooked up properly and I don't have to interpret. Yes, sir?
In the instructions, it says for all the bulbs. That's an LED diode.
All the bulbs. There's just one bulb on this one, and that's the LED. Okay? If there was another bulb on here, then you would be absolutely correct.
Is LED the bulb?
Yes, the LED is the bulb. Yes, yes. And, you know, I don't really think of it a bulb. I think of it as an LED, but I'm sure the kids now are not even going to know what an incandescent is in 5 or 10 years from now. Everything's going to be LED. So we're kind of transferring over, and we're calling them both bulbs to distinguish between the two and not have to put incandescent on everything. Generally, I will consider the incandescent just a bulb, and the LED, I will call it an LED, but in this case, maybe that's where I got to do some clarification. Let's say either LED or bulb lights, and that will avoid some confusion. So we'll try to do that in the future to avoid any confusion that you have on the exam. We're not here to try to trick you in definitions, but we want you to think about the circuits. Number 3, light or not light? You in the red? Yep. Light? Okay. You in the black way in the back? Light? Okay. You in the green?
It will light.
Light. Anybody think it won't light? You think it won't light? Okay. Anybody else? You think it won't light? You won't think it won't light. So we'll see who's right on this one, okay? On this one, this is a little bit trickier, but again, we want to make sure the batteries are facing the same direction, and they are, okay? So I don't have the batteries opposed to each other and fighting each other. So electricity is going to come up here. It's going to split off. If you look, when I draw these drawings, it has to touch the bottom, and it has to touch the side in order for it to light in this type of drawing. And I have 2 wires going to the bottom, even though it's split, and I have 2 wires going to the side and joining back up on the other end. So this one will be a complete circuit. The energy is going to go in the center, up one of these legs of the bulb, out, down, and across, and back to the battery. So the correct answer for this one is it will light. Okay? Yes?
So what you're saying is if it wasn't connected in the center there, it would not.
If the center wasn't connected, or if one of those wires wasn't connected to the bottom, but maybe the side.
Can you show what you mean on there?
I don't know if I have any pens on me. Well, here's an example right here. I think I knocked this off. But this here, see how this one would not light because it's not touching the bottom? See how it has to, here I have one touching the bottom and one touching the side.
Oh, we just thought it wasn't that full switch though. It wasn't like that. But you're saying it wasn't like
The bulb. And what I want you to do is I want you to play around with this. Take a bulb. Hook it up to your batteries. And you can do this and experiment with this a little bit at home. But if you touch it to the side and the bottom, can you see it lights up?
how did you connect it?
The bottom like it's drawn in the picture, and the side, and you can play around with this at home and try it, okay?
Oh, okay.
Okay, and see, it lights up.
Yep.
But if I touch the side,
Why don't you put that up on your document?
oh, will that show up on there? Okay. I didn't know how well this focused. Can you see this a little bit better? See how I'm touching the bottom and touching the side? if I touch the side on both of them and don't touch the bottom, it won't light up. If I touch the bottom and touch it any place else on here other than the side, if I put them both on the bottom, it won't light up. Okay? So very important to understand. All bulbs have two contacts. These bulbs have one on the bottom and one on the side. Okay? And that allows the electricity to go through one and not the other, and come out the other. Okay? Question number 3 or 4. Will it light or will it not light? I wondered if I took, can you hear me a little bit better now? Can you hear me better? No. This might be the battery thing, Mike. Oh, I got it on mute. How do I turn off a mute here?
Is there a display?
It just says mute right there.
Yeah, okay, there's a switch up there.
Okay, I probably put my hand in my pocket. There, is that better?
Don't do that anymore.
I keep this in my hand and I like to move my hand, so. Number 4, yes sir. Yes? Light? Yes?
It will light.
Yes. Light, light. Anybody say it won't light? You say it won't light? Well, let's double check and find out, okay? This is actually very similar to this, except the batteries are in series, and here the batteries are in parallel. But I have a plus, a minus, a plus, so I know that the batteries are hooked up properly. It goes around, the electricity splits, connects to one of the wires in the schematic, and this one it connects to this one, comes out and goes around, okay? So this one will light some of the electricity, half of it will go this way, and half of it will go this way, but it still will light, okay? You need a little bit more power, but it will. Yes, sir?
Both of those schematics represent bulbs, right? The one with the, say, has one.
Let me come down there and hear you a little bit better. What's that?
Both pictures both represent the same type of bulb, is what he's saying.
Yes. This is something I think because we're having a workshop, I'm not sure if I covered this in the extravaganza. There's 2 sets of pictures that I have up here, a type of drawings I have. 1, 2, and 4 are all schematics. 3, 7, 5 are pictorial. So this is how they kind of look in real life on 3, 4, and 7. 1, 2, and 4 is how you would draw it if you were drawing up a circuit on a blueprint, or how I want you to draw it up on the drawing section. You want to use the schematic and not the pictorial symbols, okay? So there's a difference between the two. I include both of them because some people can say, oh, that looks like a light bulb, where the other one really doesn't look like a light bulb or a battery.
You want to draw on the test, you want to draw a schematic?
I want, when they draw it, and we'll cover that, I want it drawn like 1, 2, and 4, not 3, 5, or 7, okay, when they draw the circuits. That's an important note, and I'll cover that when we get to that section, okay? Number 5, will it light or not light? No?
No.
No?
No.
No? Does anybody think it will light? Can someone tell me why it won't light? You don't? In the gray? I'm sorry, what was that?
He said a switch.
The switch is open, yes. Okay, very good. Anybody else? Yeah.
Also, a wire isn't connected to the bottom.
Exactly. Remember what I talked about before, where the wire's not connected here, it's just connected to the sides, and we saw when we experimented with that in real life, doesn't work, okay? So there's 2 reasons why this one won't light, okay? So I want to make sure that you understand. I'm trying to put, instead of giving you a lot of pictures, sometimes I put 1 or 2 incorrect answers in here. Number 6, will that light or not light?
It will not light.
Not light? Why not?
Because the minus is by the minus.
The minuses are to the minuses. Remember, I said the batteries have to be facing the same direction? Why I asked for the pluses and minuses, because I can't always tell when the kids draw them if the minuses are to the minuses or the pluses are to the minus. So, yes, sir? Yeah.
It won't light because the minuses are to the minuses and the pluses are not facing.
Right. Right. And you can do that at home. Take a battery, Hook them up this way, see if a light bulb lights. I don't have time to do this for this, but if you hook it up this way, they won't light. The batteries will be opposed, and that's basically the same way I just drew it right there. But see for yourself, and it's a good thing because these types of questions might be on the exam. Number 7, will that light or not light? Not light? Can you tell me why? Exactly. Remember how I said the batteries have to face the same direction when they're parallel? Here they're opposed. So what the current really wants to do is run around this way, and your batteries will heat up and die down and not light up the light bulb because there's too much resistance here. Okay? Anybody else? Short circuit. Very good. Very good. What will happen is electricity takes the path of least resistance. Wires have a lot less resistance than light bulbs. I have a short circuit here, and basically the electricity, if it was going to go around correctly, would go around here and come down and would skip the battery. It's going to take the easiest circuit it can to get back home. So you got to look for that. There will be some questions about short circuits and how they affect it. Yes, sir? What? Oh. Yeah. Good point. Last one. Number 8, will it light or not light? Why not?
Because the plus is the opposite.
Yes. On the diodes, the plus has to be to the plus side, like it is here. It's to the minus side, so it will not light, okay? And a good example of that, as long as I have that here, is I have this diode here. I got my batteries facing the right direction. We'll do this, and we're trying to set this up over here. So you can see my batteries facing the same direction, so I know it's right. Will my diodes light up this way? Nope. If I do it this way, see how it lights up? Can everybody see that? Keep it down with the camera. See how it lights up? Okay. One way, when you can look at a diode, if it's hooked up properly, when you're hooking it up during the construct the circuit, okay, the black wire here, when it lights up, is the positive end. Yellow goes to the negative end. See that? But do you notice something different between the legs of the diode? What's different about it? Yes. One's a little bit longer than the other. So on all diodes, so you don't have to check them to see if they work, the longer one goes towards the positive, the shorter one goes towards the negative. That should save you some time when you're hooking up your circuit and you're not sure. And I will always have one longer than the other on this type of diode, okay? Moving along. If you guys will take a few minutes and do 9, 10, 11, 12, 13, and 14. And we'll do this pretty quickly. Yes?
The diodes, do you guys provide the diodes as competition? Do you provide the diodes as competition?
Yes.
Or is it
Yes. One of the questions that came up is, do I supply the diodes? I supply everything for the competition. I don't have enough for 167 kids here today, so we asked you to bring your own kits, and plus you're more familiar with using your own kits. But during the exam, I will supply all the meters, all the conductors and insulators, all the batteries, all the wires, all the bulbs, all the LEDs, diodes, everything, okay?
Thank you.
So you don't have to worry about that, and I don't have to worry about this one being different than this one, and yeah. One of the questions that came up on this was, generally I have the same type of answer for this question right here. So if 10 and 11 would have the same answers, A, B, C, and D. I just didn't have room to put it on there, so that's why you're seeing, you know, a choice of A, B, C, D here and then nothing here. Basically, I'm looking for the same type of answer, okay? So if I close switch X, which light bulb comes on? Anybody?
Light bulb A.
A?
Light A.
A? Anybody say B? Anybody say A and B? Right, the correct answer is A. Goes through, runs into a roadblock here, can't go, it's going to go up, going to run around this way, okay? Question number 2, which light bulb lights when I close switch Y?
Wait. B.
B.
Like,
B?
like B.
B, okay. Anybody say A or anybody say A plus B? Okay, the correct answer is B for the same reason. You run it around, it goes through, I have my complete circuit. What happens when I close X and Y?
A and B.
A and B.
A and B.
A and B. A and B, and that's the correct answer, A and B, okay? It could be none of the above. Sometimes I've drawn circuits where it's none of the above. So you do have to check and on this type of question, okay? True, false. So you have an example. The 3 types of true, false questions I have, so you can quiz your kids, are questions related to safety, questions related to electrical principles, and questions related to definitions. And on the website, there's a list of definitions that I do ask questions on: amperage, voltage, things related to circuits, and that type of thing. So the question is, it is okay to touch electrical cords that are broken or have wires showing as long as your parents don't see you. Way in the back. Yep.
False.
False. False. Yes. False? Yes. The answer is false. You always want to stay away from broken wires, particularly wires in the house, because the voltage is so much higher. They're much more dangerous than the batteries that you're touching here with the electricity generated here. So that's going to be a safety question. Electricity can flow through an open circuit. Who didn't I ask on the boy with the red jacket there? False. Who else has an answer to the question? The girl in the black way back there. False. How about the girl way in the back? You had your hand up. Yep. False. Yes. Open circuit means the circuit is open, no electricity can go through. Okay? You want to have a closed circuit, electricity can flow through it. Example of an open circuit is going to be this one right here. Okay? And that's a principle. That's the type of thing that you're going to find out through trial and error in playing around with electricity. Definition, this is going to be a definition one. An insulator is a material through which electric current can flow. Boy in a red hat there.
False.
False. Anybody else? False. Girl in the blue there. Either one. False. Right. The answer is false. Insulators prevent electricity from flowing through it. Conductors allow electricity to flow through it. Okay? Turn the page. I'm going to ask you to do 1 through 9, and we're going to go through this pretty quickly because I know there's some sections I want to spend a little bit more time on, and then plus there might be some questions on this, some confusion, so I want to make sure we spend enough time so that you understand the basic principles of circuits and so forth.
Are we going to need to know single pole, double pole, and all that? Kids need to know all that stuff?
There won't be a lot of questions on it, but there will be a few questions, so it just depends on, you know, how quickly the kids can learn. So there's higher level stuff and lower level stuff. The basic stuff, there's a lot more questions on it, so yes. So, so, all right. Switch S1 controls which lights? Anybody in the blue?
L1, L2, and L3.
L1, L2, and L3. Yes. Yes. L1, L2, and L3. Okay? That's the correct answer. Okay? In a typical series circuit where the switch is in series with the light bulbs, usually everything's on or everything's off. Okay? And that's the nice thing about a series circuit. When you want to start doing different things, you start doing parallel circuits where you can turn one light bulb off and one light bulb on. But this is a simple series circuit. It will light and it will control these light bulbs. As it's shown, are the light bulbs on or off?
On.
On, okay. And I show it closed. and I always put the arrow in the direction that the switch can move, okay? So it's closed and it can move into the open position, which is moving away from the closed position, okay? This is an example of what kind of circuit? In the gray? Series circuit. As drawn, are the lights on or off? I already asked this, but yes, sir. On, okay? Switch S2 controls which lights? In the red over there? L2 and L3. L2 and L3 over here, okay? It's kind of a tricky question, but, oops. Yes, okay?
Can I ask a question on that?
Yes.
If that switch would have been between the battery and the first series?
Right here?
Yeah, would that have made a difference?
Yes. Then it would have controlled all three of these lights. And this is,
It doesn't control L3 because the diode.
yeah, let me get to that. Okay, yeah, technically you're right. I'm trying to put a lot of information in a short thing, and technically he's right on this. I won't do this type of drawing because there's just too much in here, but I wanted to bring up several different points and not have 10 different drawings and 10 different sheets of paper, okay? But on this, if you look, we got the positive here. This is the positive end of the diode, so the lights will light, and it really only controls L2. This diode is reversed, and this switch is open, okay? So if the switch was over here, it has the potential of controlling the switch, but only if the switch is closed. I will not get to that level of confusion. That's why I moved it over here. I just wanted you to understand that just because there's one switch doesn't mean it controls all the lights. It may control one light, two lights, or three lights, okay? Particularly in a parallel circuit, that's where that comes in. Yes?
How come it's not L2 and D1?
I'm sorry, what was that?
How come it's not lighting D1 and L2?
Okay. I like it better here because I can kind of show. Okay. I didn't on this drawing put the pluses and minuses, but on D1 the plus is going to be at the top, the minus is going to be at the bottom, okay? So the plus is closest to the plus on D1. So that diode will work. In the other case, the diode plus there goes to the negative side of D2, and as I showed you when you hooked up the batteries wrong on the diodes, they won't light up. So this is where he brought up the point, is even though S2 looks like it controls that light will never come on because someone hooked the diode up backwards, okay? And this is just a point that I want to show you, is that diodes have to be in the right direction to allow current to flow. So it's kind of a tricky question. You won't see this on the exam, but you would see either one of those two parts on the exam. Okay. Would L3 light up as shown, or which switch what lights does that control without the diodes? That's what you could expect to see on the exam. Okay?
So just to be clear, what are the two lights that light up on this one?
There's just one, well, as shown, right now, only L2 would light up.
Only L2.
L1 would light up if S1 closes, okay? So there's an open circuit there. So that's, again, it's really complicated, but there's three different important points that I want to show in one drawing, okay? Yeah.
What's the correct answer?
In the test, each one would be a separate concept, okay? So that I wouldn't be combining this trying to confuse you guys that, yes, this works and no, this doesn't work. My point is not to confuse, but in this, it's just simplified for teaching purposes. I only have to do one drawing. S1 is an example of what kind of switch? In the blue back there? Normally open? Yep, normally open. Correct. S2 is an example of what kind of switch?
When you say what kind of switch, are you only saying normally closed, or do you want to say single pole, single throw? When you're asking that question, what you're really asking for.
That's the nice thing about multiple choice questions. They will have an answer to choose from. Either of those could be correct. I could ask for single pole, single throw, or I could ask, but we have multiple choice, so it will be clear one way or the other. Okay? Good point. S2, we got two answers for S2. What's one of them? What kind of switch? Yes?
Single pole, single throw.
Single pole, single throw again. And anybody else? Normally closed is what I'm looking for on that, okay? So those are the two questions. S2 will be a normally closed and it's making contact. L1, L2, L3, even though they won't light up, ignore the diodes and ignore everything else, are examples of what kind of circuit?
Parallel circuit.
Parallel circuit, right? They're side by side. They're not following each other like in the top drawing, which is a series circuit. Series, think of circle, parallel, side by side, okay? A lot of stuff to throw at you. Some of that's confusing. That's why we're recording this, so you can go over and over it again, okay? Now I need you to build a circuit tester. Simple circuit tester is nothing more than a light bulb. You can use regular light bulbs or LEDs. This is what I'm looking for when I want you guys to build a circuit tester. I will tell you right now, there are better circuit testers than this, so you can use your creativity and make better ones. But the light comes on. The first thing you should do when you build your circuit tester is make sure the lights come on. Quite often these leads become disconnected from a light bulb, or the light bulb could be burned out. Someone could have dropped it in the event right in front of you, dropped it. It could be broke. You want to check it and make sure that you got a good light bulb. In the kits, you will always have extra equipment to make sure that it's all functioning. So you can see this works. Now you go through, and what I want you to tell me is the chalk a conductor or an insulator? Is the LED a conductor or an insulator? Or is the paper clip a conductor or insulator? And you just hook it up like this, and if it lights, it's a conductor. If it doesn't light, it's an insulator, okay? Also, while you're at it, I'd like you to check on the cards if you have time. This is a very important concept. This is an area where people don't necessarily do as well on the exam. And I want you to tell me which buttons are connected to which buttons. A could be connected to B, could be connected to J, and F could be connected to 4 different buttons. I want you to tell me which ones it's connected to. Use your circuit tester. One of the questions that came up, and I want to cover this, I kind of talked about it, how the buttons on this side will be separated from the buttons on this side. This is a multiple choice test. The questions will actually be something similar to this, where you will see numbers on the left, letters on the right. So I will ask the question, button 60 is hooked up to which button on the right? A, B, C, D. 61 is hooked up to which of those buttons? 62 is hooked up to which one of those buttons? And I want you to go down and work down it. This is the format for the exam. Like I said, the other ones are a different format, but I wanted to show you how it's going to be on the exam, just like this, where you have A on one side and a number on the other. And yours are all A, just letters. Yes, that's how I did it 10 years ago. So. Okay, I'm going to go through the meter section here really quickly because I want to focus on the last 3 areas. Our areas, one of them's new and the other 2 are worth a lot of points during the exam, and I want to make sure there's no questions on those sections, okay? The meters. First of all, I think this model of meter is $20 at Sears right now, but there's a model that's almost identical. I think I mentioned it on the website. That's $9.99. And I think the only difference is something down in this corner down here that we don't use. So $10 you can't beat it getting a meter. If you need a meter for your testing, I'd go to Sears. That way they're familiar with the same type of thing. The meter. The important things about the meter that you want to focus on. We do not use this setting here at all. This is voltage AC. This is the type of thing, I will ask a question on this. This is what you use to check the electricity in your house or in your business or wherever you're at if you want to use that. It's called alternating current, and it's very high voltage and it's dangerous. So we do not use that setting here. We do use this setting. This is the battery settings where you can check the voltage here. You can check the ohms here, and this ohms, it's right here, omega, used to measure resistance, okay? Voltage here, resistance here, current here. And I could ask questions on all of those on the battery. And the type of current this is this current has a DC on it, which means it's direct current, which is your batteries, matches with this voltage here. Will not work in this VAC, okay? There's also a setting here, and I think it's very important because I want the kids to understand the difference between using different scales. Technically, you could use just about any scale on here, but if you're measuring something with a low resistance, you're probably not going to get a very good reading on this high-powered scale. This is for high-powered resistors. So play with it at home, find a scale that it seems to work well on. Generally speaking, most of our measurements will work very well on the lowest settings for resistance, 20 on voltage. If I'm asking you to measure in current, could be one battery's right around here. I think a battery's right around 165. So you could use this one, you could use this setting here, okay? The important setting that I want you to know is, and I want the kids to get familiar with the equipment and what they would be used for. So I usually ask a question on this. The voltage on this battery, I'm giving you an answer. It's printed if you want to look at it, 1.5 volts, okay? Almost all D-cell batteries, they'll be a little bit higher if you measure them, 165, 180, somewhere around there. They're a little bit more, but they're generically considered 1.5 volts. So if you're going to measure something on this battery, it would be real good to use this scale that matches up here that says 1.5. You're going to get the highest accuracy than you would if you were to use something at this scale here, which would give you very low accuracy. So the difference is, and this may prove me wrong, I didn't do this in advance, so it could make me a liar, but this is only going to read one, okay? And if you want something with a little bit more detail, like I said, you could go down here, where it's actually 1.61, or you could go down here and it's showing actually 1.49. So this one's going to be a little bit more accurate than this, and it's going to be a little bit more accurate than this, okay? And that's the concept I'm trying to teach here. So when I say, if I'm measuring the voltage of one battery, what setting would I use? Technically, the 20 and the 1.5 volts are correct, but the 1.5 volt usually gives you a little bit more accurate reading. 9 volt, that could be used if you had two batteries in series. It's going to give you a little bit more accuracy than the 20, and it will also be used to measure a 9 volt battery if you wanted to measure that, okay? That's why this setting here would be used to measure like a 9 volt battery that you put in your smoke detectors and that type of thing. You know, the one with the two posts at the top. I think I got an example here. A little bit different format. It's usually square, has two posts at the top, so you can't reverse how you hook them up. You can't put the switch on, the connector on backwards. It can only go on one way, okay? But I usually ask what reading. I will never ask a reading where it says, what's a better setting to read a battery, or which setting would you use to measure the voltage of a battery? I would not put 1.5 volts and 20 in the same question, because some people like the 20, some people, meters don't have the 1.5 volts and they're not familiar with it. So I would ask something like 200, or maybe the 200 micro versus the 1.5, where you saw when I set it here at this reading, it really didn't give me a very good reading at all. Just give me one whole number, one, which doesn't give me, 1.5, 1.6, 1.4, whatever it is. Yes, sir?
What if you have one that measures temperature just like me, and it measures everything else, and it doesn't have 1.5 voltage, it has temperature?
You have a very good meter right there. That's one of the reasons why I recommend, even though your dad may have one of those in-house, get one of these, because the scale's just a little bit different, and I want you to understand how the meter works. And what's even more confusing is maybe voltage DC is on here on mine, and on yours it's down here. So when I ask you to measure voltage, you may go right up here or right down here to measure on your meter, and it's going to be in the wrong location. So it's one of the reasons for 10 bucks, you really can't go wrong. Pick up one of these, and it really helps the kids avoid some confusion. That one does work, you just have to understand the differences between them, okay? And that's where that 20, if you have a 20 on yours, would be the correct reading to use on yours. Which one?
The one that has sound.
Does it say auto on it? You can play around with it and find out which setting is the best one to read and learn through trial and error. That's usually the best thing to do is figure out which setting you like that you feel most comfortable with using to take your measurements. Okay? All right. So to measure the voltage of a battery on the table, you would be what setting? On my meter, it would be BAT. Okay? On his meter, it would be VDC, right? Okay, so just depending on the type of meter that you have. I purposely didn't put VDC on here because I didn't want to have confusion. I want you to make that you use BAT. To measure the current output of a battery on the table, you would use what setting? Correct answer is ADC. We're looking for amperage, A, and we want to make sure that it's DC because that's the type of electricity that comes out of our battery, okay? What's that? ADC, number B, okay? Ohms is used to measure resistance, not current. VDC is measured voltage, direct current, or voltage AC. The correct answer is amperage, measures current, so it's ADC.
And then, I'm sorry, can you go back up to 1 again?
Yep.
Why is that, I'm not trying to answer that.
Why is what?
Why is that the answer is BAT?
BAT? Because voltage AC is the type of electricity in your house, not in your battery, okay? BAT is the correct answer. ADC measures amperage, not voltage, okay? So that's a wrong answer. Ohms measures resistance. Use that to determine if something's a conductor or insulator. Conductors have very small values, numbers. Resistors have very large, or insulators have very large values. I did have VDC on here, so this is a bad example. VDC would be also acceptable. Usually, I don't include that if I have the bad option. You'll have one or the other to go from. So this one, if you gave me either one of those two answers, it would be correct. Okay? Good catch. If I have two 3-volt batteries in series, and I use whole numbers because I don't know how many of these kids are good with fractions and decimal points and stuff like that. We don't have any 3-volt batteries, but if we did, if 3-volt batteries were in series, what would be the voltage of my circuit? 6 volts. Voltage and resistance are always added together, okay? So when I don't have you do anything like the current through a parallel circuit where that's fractions and that gets very confusing, I'm looking at just basic things that say that if I put my batteries, and it's an important concept.
Number 3.
Yeah.
Yes. Please skip.
Oh, I missed 3. Sorry.
Okay.
Let me finish 4 and then we'll go back to 3, okay? If I hook my batteries up this way, and say this is a 3-volt battery, it's not, so you measure it, it's going to be different, but it would be 3 plus 3 is 6, okay? If I hook my batteries up this way in parallel, the voltage is the same. It's going to be 3 volts, okay? And you can measure this, these are 1.5 volts, so actually this is going to be 1.5, and this is going to be 3 if you were to measure it, okay? So it's an important concept to know the difference if batteries are hooked up this way, or if you hook them up this way. And that's the concept I'm trying to teach here, okay? The resistance of a penny is approximately, we don't measure resistance with voltage, so that's wrong. We don't measure resistance with amps, so that's wrong. We don't measure resistance in amps, so that's wrong. We measure resistance in ohms. So I said a penny is a conductor or an insulator. Does anybody know? Conductor. And what did I say earlier? Conductors have very small values. So if you were to not even use a meter and measure it, which one would you guess of these two is smaller? Yes? 0.3, right? So an insulator might be 110, or it might be 1,000 or something like that, or 10,000 or something, whatever the meter, max of the meter is, but the conductor is going to be 0.3. And if I ask this type of question, usually I have orders of magnitude between the answer. I'm not going to ask you 0.3, 0.4, or 0.5, because particularly when you're measuring batteries or something like that, they change over the course of the tournament and they could vary, and I don't want that. So orders of magnitude, you should be able to tell just by looking at what is the correct answer, but if you're not sure, measure it, okay?
I'm sorry, number 4, what would it have been if it was parallel? I didn't catch what you said.
If two 3-volt batteries were in parallel, the correct answer would have been 3 volts, okay? In parallel, you do not add voltages. They are the same. In series, you add them. So series, if you think of a circle, this has a certain amount of voltage, and I'm adding it to this, and it's going this way. So this adds to this and gives you a final answer, okay? When I hook this way, the voltage is still going this way, but it's not going to something else. It's side by side, so there's no way that it can increase, okay? This is the rest of the time that we have here. Well, actually, I'm going to cover something first. I didn't ask any questions on this, and I apologize. This is something very important that you cover. Don't know if we can see it all. This sheet is available on the website. You also have a copy. This is the one I will be using. This is the type of questions I will be asking, and this is the type of question I will use. 3 bands here, 1 band here. So it's called the 4-band resistor. There will be no questions on this, okay? It's just was on the sheet that I printed out, and I couldn't find one that I could print out with the detail that showed just this one. So you can ignore this part here. Yes?
Will they have the grid, or do they have to memorize that?
Would they have what?
The grid. Will they have this?
Yes, yes. They will have everything. They will have the questions at the top. This whole sheet is what is at that station. And this is what the kids work off of, okay? So this is exactly the same thing that they should be using. The bands are all worth different values. The first and the second band tell you what number it is. It's a 2-digit number. The third band, we're ignoring. So the third band on here is actually the multiplier, okay? And the last one is the tolerance. And I'll ask questions on all of these. I'm more concerned with this information, a little bit with this, and I'll ask maybe 1 or 2 questions on this. So if I had a resistor that was yellow, orange, and black for the first 3, that would be 4, 3, times 1, so that would be 43 ohms, okay? If I had one that was gray, well, let me pick here, blue or green. Green, 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 it would be 5 times 100K. Okay, K is 1,000, which is 3 zeros. So you have 5, 5, and then 5 zeros, okay? So it's kind of easy. This is the number, if you look at this, the easy way to remember this is the number of zeros. So there's going to be 1 0 on this one, 2 zeros on this one, 3 zeros on this one, 4 zeros on this one, 5, 6 zeros on this one, okay? So I don't know how many of the kids are familiar with, you know, K being 1,000 and that type of it. So that's how I think of it. If you can think of that in the same manner, that's a good answer. So a blue and a green would be 6, 6 times 5 plus 5 zeros, okay? A brown, red, and red would be 1, 2, and 2 zeros, okay? Is that clear of how that works? The answer is right here on this one, so you can kind of figure it out, work backwards if you want. I don't typically ask 560K. I could ask that, or I could ask the zeros. I don't know what's easier for you guys to understand. If I go 2, 2, and this one, that would be 22 kilo ohms. I could do that, but I think the zeros are a little bit easier. Yes, sir?
How do you know which side to start at?
The side that has the most lines. So one side will have 3 lines, or 4. One side will have 1. This one is the tolerance, and basically this just tells me the accuracy of the resistor. The kids don't need to know a lot about that, but just know that if it's brown, it's plus or minus 1%. This one's silver, so it's going to be plus or minus 10%. Okay? That's basically just all they need to know. They can just literally look at it, look down here, and check and see if that answer is available. Okay?
So do they add the first 2 bands, or is it?
No. No. It's a 2-digit number, 43, 55, 76, and then some zeros following. Okay? So it's the first number, the second number, and then the zeros. Okay? All right. I hope that helps you out. Last thing that I want to work on, and we'll stay as long as you guys need some help with this, could take some time. I have 3 circuits I want you to draw and 3 circuits that I want you to construct. Not all of you can construct the last one because some of you only have 2 batteries. It might be a little bit difficult. The lights may not come on if you don't have enough batteries, and I'm not worried about that, because sometimes the wires come disconnected when the kids construct a circuit. If the kids are constructing a circuit and this wire's laying right here and I take a look at it, I know that it's supposed to be connected. Sometimes when the kids are moving batteries and switches and so forth around, they alligator clips will disconnect. So I don't count that against them. I just want to make sure they understand the concept. One other thing that I do have that is available during the construct, and they need to know, single pole, single throw circuits look like this. Single pole means it has 1 set of contacts. This can only touch in one place. Single pole, single throw means it only goes in one direction. Doesn't go in this way, only goes in this direction. Same circuit. to have 7. We just had a couple districts that had so many teams that I had to have an extra station, okay? Typically, the first 4 or 5 stations are going to be Scantrons. We are not using Scantrons this year. We're using zip grades. There's going to be examples of them on the website. They look a lot like Scantrons. The nice thing is you don't have to use a number 2 pencil. You can use a pen, you can use any type of pencil you want. It is much easier to read, yes, and not be confused by how you filled it out. So we think it will help the kids give a better accurate score on there. A lot of times the kids fill in the circle and they fill it in a little bit too large. Scantron thinks it's 2 answers instead of 1 and will mark it wrong. So we're hoping that this works better. So the zip grades, the last 2 stations are always draw the circuit and construct the circuit. And those are always stations 6 and 7 or 5 and 6. So when the kids go in, if they're very confident, they can go up to those stations first. If they're not so confident and want to ease into it, they should go to one of the easier stations. Usually 1's the easiest, 2's a little harder, 3's a little harder, all the way up through 7. Okay? Oh, very good. Okay, 2 LED bulbs in parallel. Okay. Okay. There's only one thing I would mark wrong on here. No, there's 2 things that you didn't. Okay. 1, there's no switch. Okay.
Oh, I forgot to look at
Yep. Okay. Yeah. And I didn't put a switch on here, on this one. And the second thing is I want plus or minus on here, okay? So I know that you have it hooked up directly, because if you put the minus on this side, then you won't get credit. So that's why I asked for that, okay? Those are the 2 things you would have to do right. Yeah, oh, you return these? Just leave them here. Thank you very much, guys. Let me look at my question. Where's my questions at? Here it is, okay. Yes, but you need to put the pluses and minuses on here. And this is very important. So you put a plus and a minus here. And what did we say, will it light if the minus is close to the plus? Yes or no? No. So you got that backwards. So if you're going to put your batteries this way, you have to draw it like this. Okay? Okay, thank you very much, dear. Yep, very good.
Just wanted to say thank you.
Good. Yeah, I'm glad we had a great turnout. I hope this helps you guys quite a bit. So this is really nice to see. So.
Do you think you're going to have any schematics with the resistor?
With what?
The resistor?
No. Nothing with a resistor. Right now, the only resistor we have is the light bulbs. So I just consider that a resistor. And it's a more positive feedback for the kids that they can see it. I have asked them to use diodes because I want them to understand will current flow or not flow. But typically if I use a diode, it's either going to be an LED or in combination with a light bulb so the kids get visual feedback. Is it hooked up in the right direction or is it backwards? Okay, and that's the things I want them to work on.
And one more question. On the, during the exam part, are they going to need, I know with the Scantron, they had to know which question they started at.
Yes, same thing.
Okay.
Will be the same thing. That's the one thing we do is I ask for lots of volunteers, and the 2 things that the volunteers do is that kids are putting circles and not X's in, and that they're starting at the right location. So if they have to start at location 40, someone's watching to make sure this group is starting at 40 and this group is starting at 40, and it's not wrong. Every once in a while we do miss it a little bit, but I mean it's really rare. Maybe 1 out of 80 we might miss, but we usually catch it within 3 questions, and we just ask the kids to go back and start here versus there and just erase that part. So, okay? Yes.
You will put the resistor color chart on the table.
Yeah, did you get one?
No, I mean, it's in the kit, but you don't need to remember those.
No, it'll be on the table.
Okay.
No, this year it's going to be on there.
I thought you need to remember those.
I talked about it at the extravaganza, the coaching clinic, that I might have the kids do it during county. If I do, I will notify you on the website, but that's only if 70% of the kids get all the questions right. Then I got to make it a little bit more difficult. But right now, district, right now, no, the kids will have everything available just as they have it. Okay, and yes, it's just I gotta, like I said, I can't have 7 teams tied for first place. Everybody gets upset, so I have to make something a little bit more difficult, and that's one of them. So yeah.
When they build the circuits themselves,
Yes.
Whether they're using LEDs, diodes, anything,
Yeah.
are you going to check to make sure that
Yes.
the light's light? Are you going to check to make sure that the, like for instance, when they do it, when we're doing it and the light bulb doesn't go off, they're freaking out. It's connected properly,
Yes.
but the light still isn't going on because of,
I am working very, very hard to make sure that the lights will always come on. But I've always told the kids in the past that the lights may not come on, and don't freak out. Because what may happen is the team in front of you might do that, okay? And there's no way I know that this is broken or not just by looking at it. If the kids think it's broken or think it might be, I pull it out and put a new one in so that they have one. But there have been times where the kids have checked them and found out that they're bad. But as long as I can visually look at it and see that it's done correctly, they get 100%, okay? The neat thing is to have all the lights come on, because then they know that they did it properly, right?
And is it going to be written out the way that, like with the papers that you gave us today, written like this? Or are you going to give them the schematic symbols and then have them go from the symbols?
Both.
Both, okay.
Okay,
All right.
there will probably be one question of each at the districts. I'm going to see how they do on that, and then I'll determine how many of those questions at county. If they do very well, I might do all schematics at county. If they do very poorly, I might just do all written out. It just depends on which ones the kids, I don't want to overwhelm the kids, but I don't want the kids to be too easy. So I look from districts and decide what types of questions I put at county. But train for both, that would be the best thing, okay? I'm going to try to trend more towards the schematic than the explanation, but some of these kids have been doing this for 2 or 3 years. I don't want to change on them in the last minute, so I'm going to ask both types of questions, at least for 2 or 3 years, and then we'll phase up probably this method out and just have schematics and have them construct it. Yep.
All right, well, thank you so much.
Sure thing, yes.
How complex we can expect? Like, will it be this level of complexity, or is it going to be more complex? Basically,
There will be one that will be very complex.
okay, there will be
There will be one.
one.
Okay.
And this will be generally 3.
Usually,
You never
Dirt.
put an example of that complex one.
well, I don't, because to tell you the truth, there's only 2 or 3 ones that I ever use for the really complex ones. Sometimes this is all I use. Sometimes this right here, 20% of the kids will get this right. So I'm like, okay, that's my tough question, because that's what I'm usually looking for, is something that 10 or 20% of the teams will get, and that helps me define, 1st through 10th place versus, 30 through 50th. I don't expect everybody to get that.
Now with the new Scantron, it will allow you to give a percent.
They do not use Scantrons for drawing or for construction. It's all visual checks by me. Yes, I grade
So
those
if they
on.
get part of it right, you should give partial credit, even if it's not, since it's
I have always given them partial credit in the past, and I will continue this year. And I'll tell you, I'm really torn between it, because I'll get kids that will hook 3 batteries on there and 2 light bulbs and not have anything hooked up. And theoretically, if I ask them to hook up 3 batteries and 2 light bulbs, that's correct. So I got to give them partial credit on it at the very least. And that's 2 out of the 3 sections that they got right. So they could get 2/3 of correct without even drawing a single line on there. But on the other side is, I don't want the kid to have everything real close and then forget to put a switch closed or open and get 0 points. So I'm giving partial credit, and I'll probably continue to give partial credit, but that could change in the future.
hard ones that you throw in there.
Oh, the hard ones, yes. Yes, the hard ones, the kids will get partial credit. And what I do, okay, when I give partial credit, and if you get 100% correct, then you usually get a 50 to 100% bonus. So if that question's worth 10 points, they could get 15, or a total of 15 or 20, 5 or 10 bonus, depending on the complexity.
So that's why we didn't see
At
a
the end.
schematic of it, because if you showed it.
So if they do it properly, I want to make sure they